Right, so question 2, really similar. In fact, it's almost exactly the same. So the first part gets you to prove that if n is divisible by 23, then m is divisible by 23. And then it's going to use those ideas to do an iterative, or they're calling a recursive process, to show that 2001 is divisible by 23. So the only difference with this part is that they haven't told you how to link n and m, and m has been written round a slightly dodgy way. So this is the first part. So this is similar to what we were doing again. So I'm going to write n in terms of n. So I know that n is 10t. I know that somehow I would feel that was easier if I wrote it round the other way. I can see that n is 10 times, obviously, my m expression, and that's going to give me 10t plus 70q. I don't want 70q, so I need n to just have 1q, so I'm going to have to subtract 69q off that to make it work. So I think I've written n as 10m minus 69q. So I've managed to connect them. Right, again, it's an if and only if. So first of all, I'm going to assume if m is divisible by 23, then I know, and you should be starting to feel quite familiar with this bit because we've done it loads, that m is a multiple of 23. So n will be 230, so 10 of those, 230 minus 69q. So I want to show that n is divisible by 23, so all I do is I take out a factor of 23, and I've got n is 23 bracket 10 little m minus 3q. So I can see instantly that n is divisible by 23. I'm now going to do in the other direction. So if n is divisible by 23, I know that n is a multiple of 23. So I'm going to go back into my definition, my link between n and m, and I'm going to rewrite capital N. So 23n is equal to 10m minus 69q. I'm going to get that 10m by itself. So 10m is going to be 23n minus 69q. So 10m is 23n minus 3q. So I can see that 10m has a factor of 23, but I know that the highest common factor of 10 and 23 is 1. So I know that because 23 is not divisible by 10, m must be divisible by 23. Stop. Right, so the second part of the question. So again, it's setting up this kind of iterative process, well, I call it recursive process, where you have shown that numbers written in a certain form are divisible by 23. So all you're going to do is exactly the same thing again. You let your first value equal, so we want to show that 2001 is divisible by 23. So we let our first thing equal 2001. So it wants you to rewrite your first value in the form of 10 times a number plus y. So you know that 2001 will be 200 times 10 plus 1. So x is 200 and y is 1. It's then telling you that how you're going to break it up to get your second value is x plus 7y, and that's because that's what you used in showing that your m and n were both divisible by 23. So m1 is going to be x plus 7 lots of 1. So m1 is going to be 207. Now we're still thinking that we're not ready to show that that's divisible by 23. So we're now going to take 207 and break it up in the same way as 10x plus y. So that's going to be 10 times 20 plus 7. So x is 20 and y is 7. You're then going to put that back in to get your next iterate. So m2 will be x plus 7y. So m2 will be x plus 7 times 7. So that's going to give you m2, which is 69, which we know is 3 times 23. Therefore, we know that 2001 must be divisible by 23. So this is the last question. Now this one's slightly different because it gets there much quicker, because this one is getting you to write the number you want to divide as 100a plus b, where b lies between 0 and 99. And you've still got, it's telling you how to do your second number, a minus 9b. Now, the only difference, and I'm not going to go through again because we've done it so much, proving the if and only if 17 goes into m. The only thing that you're going to have slightly different is slightly bigger number. For trying to connect them to do that proof, you know that n is 100a, so I'm going to get 100a minus 900b, and you don't want 900b, you want 1b, so you'd have to add 901b onto it. So the way that you would connect them is n is 100n plus 901b. So that's a way, if they're not going to tell you how they're connected. But we've done loads of those, so we're going to go straight to B and show you how it works when it's slightly different, and they're going to get you there much, much quicker. So it asks you to show that, what have you got here? You've got 22,557,198 is divisible by 17. If you look back at the notes where it's quite a complicated explanation, it does say that you can have negative values. So we could show that a negative value is divisible by 17. So it does, because this is 100, it's not quite as good as having a 10, but you know, you've got to be ready in case they ask you to do it. So your first value, we're going to show divisibility of 22,557,198, and that is wanting you to write that in the form as 100 times something. So that's going to be 100 times 225571 plus 98. So you can see you have written that in the form y lies between 0 and 99, and there's your x value. Now to get your next value, they're telling you it's x take away 9y. So m1 is going to be 22557 take away 9 times your y value, which is 98. So m1 is going to be 224689.
There's a digit
That doesn't
missing.
look right.
There's a digit missing off the 22557. There should be a 1 on the end, I think. Just the one.
There it is. Right, That was it. Was it missing one? Right, we'll carry on. So 2, 2, 4, 6, 8, 9. Okay, you're now going to break that up again as, you're now going to break it up again as 100x plus y. So you can see to break that up as 100x plus y, you're going to have 2, 2, 4, 6 times 100 plus 89. Again, it's in the form of a number times 100 plus a number that lies between 0 and 99. So there's your x and there's your y. So M2 is your x value. Try and write it out correct this time. Take away 9 lots of your y value. And if you work out M2, it's 1, 4, 4, 5. Now we're still a little bit away of showing that that is divisible by 17. So again, I'm going to break it up as a number times 100 plus a number that lies between 0 and 99. So x is 14 and y is 45. And then to get your third iterate, and this time I think it's going to become negative because obviously you're going to be subtracting from 14. It's 14 take away 9 lots of 45. And I think that's going to give you minus 391. So now with your minus 391, you know that minus 391 is divisible by 17. 17 goes into that. Therefore, we would say 17 goes into our 22 million. Where was it all the way back? 557,198.